These first few problems really are as simple as they look. We're just taking the square root of 36, which is 6. A lot of these early problems, too, will be problems that you can put in your calculator, right? Until you get to one like this. Like now we know that that negative under there means it's an I, and the square root of 49 is 7.
So we can't put no solution.
So by the time we get to problem number 3, we've introduced variables under the radical. And this is when we started talking about the Josh rule, right? So, square root of 81, 9. That one comes out completely. 2 divided by 2, 1x comes out. 5 divided by 2, 2y's come out with a remainder of 1. Number 4... Notice that we've changed our indice, right? It's going to come out 2 and 27. Somebody tell me why we're going to stop right there. So then the cube root of 27 come out as a 3, and the 2 had to stay in. Okay? All right. 5. 4th root.
You're going to send this to us?
I will. Yep. So we still have the 4th root. 4 times 4 is 16. Add the exponent, so we got x to the 6th. Of 16 is 2. So 1x gets to come out. 2 x's have to stay in. You good with that? Okay. Rolling on. Number 6. Now notice what just happened there. 6 square roots of 7 minus 1 square root of 7 is 5 square roots of 7. All right, hold on. Here we go. We'll slide that down. This is fun. All right, 6. Let's go back and grab 6 in. Oh, there it is. Negative cube root. Negative 27 r to the 15th. All right. So there's a negative sign sitting outside that radical. So let's make sure we don't lose that negative sign. The cube root of negative 27 is negative 3. Josh rule. 15 divided by 3 is 5. Did anything have to stay in? Nope. Negative times a negative makes a positive. And so that would be that final 7. Square root of 5, square root of 45 is smash them together. Right? 5 over 45 is a fraction that reduces. And that's what we hope happens, because the square root of 1 is 1 and the square root of 9 is 3. And so that would be our final answer. Number 8 is a very similar problem. 4th root of 1, 4th root of 81. And if it would help to smash them together, we would. So the 4th root of 1, 4th root of 81. Okay. Let's jump down to number 10. It. Okay, and then from here we FOIL. First outer, inner, last. Simplify. Square root of 9 is 3. Those are the same, so we can add them together. Minus 1 is minus 2. Those numbers can be smashed together. 3 plus 1 is 4. Minus 2 square roots of 3. And that would be your final answer. Number 11 is when we jump into fraction exponents. X to the 2/3 times x to the negative 4/3. The rule says that if my bases are the same, I add my exponents. Two fractions already have a common denominator. 2/3 minus 4/3, x to the negative 2/3. And you'll remember that negative exponents just cause it to flip to the bottom. So that would be the more correct answer. Number 12. Cube root of 2 minus 4. Cube root of 4 plus 2. And this looks a whole lot like FOIL, doesn't it? Okay. So first comes first. Cube root of 8. Outer plus 2 cube roots of 2. Let me make sure you can see that is a cube root of 2, not an exponent. Inner is minus 4 cube roots of 4 minus 8. Anything that can simplify will be simplified. The cube root of 8 we know is 2. Can we put these two radicals in the middle together?
No.
Tell me why not, Aaron.
Because they don't have the same.
They're not the same, right? One is the cube root of 2, one is the cube root of 4. If we could simplify them, we would, but we can't. They're not the same, so we can't put them together. We can put the 2 and the negative 8 together and get negative 6 plus 2 cube roots of 2 minus 4 cube roots of 4. And then that'd be your final answer. Okay? Number 13 says we're going to write it in exponential form. So in other words, they're giving me a radical form. And when we rewrite it, we only want to use exponents. Okay, so here we go. I know I've got an 8, and I know I've got an x. The 8 is raised to the first power, taking the fifth root. So first power, fifth root. The x is raised to the third power, taking the fifth root. So the third power, the fifth root. And then that would be your final answer. All right, 14. Again, we're just rewriting it. And Trey, I think this one gets a little closer to what you were talking about. Notice that whole grouping there, 2x plus 5, the whole thing has been raised to the second power and the third root. And so this is just a rewriting of that radical expression. All right, starting with problem number 15, we're rationalizing denominators. In other words, we've gotten to the place where we can't have a radical in our denominator. Okay. Just got confused on the first test. Okay. The cube root of 64, which I'll go ahead and show you the punchline, it's just 4. And when I multiply the top, that is the cube root of 4 times 4, or 16. And unless there's a perfect cube in 16, like we would be done here, 8 times 2 is 16. 8 is perfect. So the cube root of 8 is 2, which left a 2 under the cube root. And then again, so Jordan, this is where I've got stuff on top and bottom that match. And so that 2 on top and the 4 on bottom would reduce. And that would be your final answer. Okay. 16, we take a step up the ladder here. And now we don't have a single radical on the bottom. We have a radical expression, conjugate pair. First and second term stay the same. We change the sign in the middle. And then we FOIL. This denominator times this denominator. The numerator is going to be distributed to that other numerator. And anything that can be simplified will be simplified. So here we go. First times first would be the square root of x squared. We're going to simplify that in just a minute. Outer is minus the square root of xy plus the square root of xy minus the square root of y squared. These go away. Plus or minus xy, those go away. Square root of x squared is x. Square root of y squared is y. Minus sign in the middle. So our new denominator is x minus y. Let's see if anything simplifies on top. Let's go ahead and distribute. Square root of x times square root of x will give us square root of x squared minus the square root of xy. This one simplifies. Square root of x squared is just x. And so x minus the square root of xy would be our final answer. If something would simplify, we'd simplify it. 17 is when we start solving equations. Step 1. The radical has to be isolated. That radical has to be all by itself. It is, so I need to do whatever it takes to get rid of that radical. And in this case, because we're taking a square root, we're going to square the whole thing. And then we solve. And I'm not going to do it here, but I'm going to remind you, check, check, check. Right? Because if it doesn't work out, then you have an extraneous solution.
Doesn't work out right there.
On number 18, they changed the game just a hair because we put radicals on both sides. Okay, so not that it matters on this problem because we do have radicals on both sides, but because that index is a 4, we're going to take both sides and raise it to the 4th power. So we raised it to the 4th power because that matches our index. That cancels out our radicals, and so then we have an equation that we can just solve. Subtracting x from both sides. Subtracting 1 from both sides, x equals 7. With 2 radicals, we probably want to make sure we check it. Looking at i's a little bit, notice what's in between the parentheses And so this one says that we're just subtracting terms. Numbers and numbers, i's and i's. 2 minus 4, negative 2. Negative I minus 3i. That's minus 4i's. And this is just collecting terms. Like we're just putting stuff together that matches. 21 on the other hand, there is nothing between the parentheses. So this one's FOIL. First times first. Last. Outer. Inner. Last. This one just happened to work out where the two middle terms cancel out. That's not always going to happen. Remember that I squared is negative 1. So minus the negative 1 is plus 1. And now this adds together and you just get 17. Alright, and then 22. 22 is another one of those where we're rationalizing. In other words, there's an I in the denominator. And I don't need an I in the denominator. So I'm going to go get my conjugate pair. Because that's how I get rid of radicals and imaginaries in my denominator. Okay? So we're going to FOIL. First times first. Outer. Inner. Last. We built it so that my middle terms would cancel out. They did. I squared is negative 1, which makes that a positive 9. So 16 plus 9, or 25. That's my new denominator. 2 times the other numerator, and we could leave that one right there. Distribute, don't distribute. Like it doesn't really hurt the problem either way here. Either one of those would be fine.